Okay? You know what this word means? You do? Oh, that's good. I won't have to explain it then. So, anytime we're graphing a couple of lines, we're going to be doing this a lot the next, how many days do we have to go here in this course? 18, 17, 18. Okay, what are your possibilities? It's always going to be, when we're graphing a linear relation, I told you it's going to be linear. It's going to be a line, okay? You could have something like this. There's two lines. What do we notice about those lines? They cross. What other choice is there if you have two lines on a graph? What's the opposite of what that was? What if they don't cross? Those will never cross because this is the way we denote their parallel. We put little arrows in both. You can't see that, it's right on the axis. Okay? Either two lines are going to cross or they're not. Okay? That's parallel. Those are parallel. They won't cross. If they're not parallel, then they will. We're also going to look at another situation here today. I'm going to talk more about that. Okay? There is actually another possibility, but I won't say it today. What if they cross so that they make a right angle? What's another word for two things that make a right angle? These things are... Hey, look at the title. Parallel and perpendicular. And if you forget what parallel means, sometimes these words have meaning. You see those two L's? They're parallel in the word parallel. Isn't that cool? All right, let's not worry about all this transformation stuff. I'll show you one in a sec. Here is line segment AB. I want to draw another line segment. If I translate this line 4 units right, that's a translation. It's just a movement, like Tyrell's doing right now in his chair. 4 right and 1 down, how would we draw that? Well, I mean, visually, don't look at the whole line. Just start with a point. Let's start point A. 4 right, 1, 2, 3, 4. And then 1 down, it's going to be there, right? How many points do I need to make a line? 2. How about I do point B and then join them? 1, 2, 3, 4 right and 1 down. And there's my new line. Not a great line, but that'll have to do. They're going to call that one CD. Okay? What do I notice between AB and CD? Hey, what does that say? Yeah, parallel. Okay? That means they will never cross. If there's arrowheads on the end here, this doesn't say that. It's just a segment. But if I put arrows there, they go on forever and ever and ever. What's the domain of AB? Yeah, we don't say infinity, but I know what you mean. All real, right? Every value of x you could possibly think of. A will get there, all the way to negative infinity. B will get there. It's nice to review as we're talking about this stuff. Okay. Anyway, these are parallel. Okay? Let's calculate the slope of these guys. We already kind of think we know what's going on here. Do we know how to calculate the slope of AB? Okay, slope, again, that's the slope. Its definition is rise over run. If you got a picture of it, then you just look. What's the rise? 1, 2, 3 units. Okay, and let's write. That's AB. What's the run? 1, 2, 3, 4, 5, 6. Can I simplify that? Yes, then I should. Do I want to make it a decimal? No. And let me explain why again. Don't write this, but 0.5, yeah, half's 0.5, but we're going to be going backwards. I'm going to give you this and say, what's the slope? You're going to need to see what the rise and the run is. Here you can't see it. Here you can. So don't make it a decimal. It's not helpful for this chapter. We always want to have rise over run. Just like if we say your slope is 2, well, what is that? Is that the rise or the run? I don't see a fraction part. How do I make just a 2 a fraction? Yeah, okay. So there is the rise over the run. So that line, if I was to say graph that, we're going to go, let's say it started at the origin, 2 units of rise, 1 unit of run in the positive direction. Okay, that's what that line looks like. Okay, you want to see it as a fraction. If it's just a 2, put a 1 under it, right? Okay, so that's that one. Let's look at CD. The slope of CD, what do we expect if they're parallel? Do they kind of look like they would have the same slope? Yes, they kind of do. Well, let's check it out. This is 1, 2, 3 over 1, 2, 3, 4, 5, 6. Hey, what do you know? It's the same thing, okay? Conjecture. If you take Math 11 Foundations, you're going to see this word like 20 times. They love it. What's a conjecture? This is English. This isn't math. Okay? What's synonymous with conjecture? Guess. Make a guess about the slopes of parallel line segments. Well, we've already said it 2 or 3 times. What do we know about parallel line segments? The slopes are the same. Okay? Always, always, always. And it seems easy, but I'll give you a question and you'll forget that. Okay, you need to know that to solve the problem. It'll say 2 lines have the same slope. Da 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 da. All right, 2 lines are parallel, and you'll forget. Oh yeah, the slopes are the same. That's what you need to know to solve the problem. It's just a different way of asking the question, right? It's taken out of context. You ever see that? Like sometimes you see someone in a certain situation, you know who they are. And the older you get, the more you experience this. And then you see them in a different place. Like you go to some sporting event, and there they are, and you're like, who's that person? I know them. I know them. But you can't think of their name. You can't think how you know them. You just know you've seen them before because it's a totally different context. It's kind of like that with word problems in math, right? If they ask it just a little bit differently, all of a sudden now you're lost. You could have done the same problem 10 times, but they just change a couple of the words, and now you're like, what? I don't get it. What are they asking? Okay? Okay, so parallel, that's not too bad. Perpendicular, there's a couple more bits to it. Investigation. Now we're going to, on this grid plot, this Cartesian plane, we're going to do the point 5, 2. 5, 2. There it is. Draw the line joining that point to the origin. What's the origin again? What's the coordinates of the origin? 0, 0. All right, there's a line. I'm going to pull my ruler out. God. It's not as easy as it looks on this tablet, right? But I used a ruler and it still gets wavy. See, it's just, it's just digital, right? It's not the same as analog. Okay. Rotate this line through an angle of 90 degrees. This is a little tricky. You're not going to do this on the test, okay? This is like review. You did this in grade 9, okay? You did all this rotational stuff. It's a visual skill, all right? But how do we do this? Well, to get to this point, I went east, if you like compass. There's north and south. How do you know which one's west or east? If you're dyslexic, you never get this right. You do the soggy wiener thing too. Have we talked about this before? We. It spells we, not you. Okay, we. That's the easy way. If you like wieners, fine. But how do you know if you go clockwise or counterclockwise? right? I mean, I'm not a good memorizer. Okay, to get here we go east and then north. So if I want to rotate this 90 degrees clockwise, I'm not going to go east first, I'm going to go south, right? So I'm going to go south 5 instead of east 5, okay? And then instead of going north, if I rotate that, now I'm going to go east. So if you followed that, great. And if you don't, well, don't worry about it. It's not going to be on our test. That's this rotated by 90 degrees. Does it look like a right angle there? Kind of does, doesn't it? Does that look like about 90 degrees? So to get this point, go -5 and 2. Okay? That's the point 5, 2, rotated by 90 degrees clockwise. Turn your head sideways. Put your eyes along this line, and then it'll look, because we always want to see right angles like this, right? We want to see a vertical and a horizontal. This, neither is this. But if you turn your head sideways, you look at it, and then you go, oh yeah, it does look like 90 degrees. Okay. Anyway, let's find the slopes of these two perpendicular lines and see how they compare. So the first one, that's point A. What do I want to call this point? B, kind of makes sense. This is point O. So the slope of OA, how do I do this? Well, graphically, you can just count. Remember, I could get the 2 points, use my slope formula. All right, either or, because there's a picture there, I'm just going to go, what's the rise? 2. What's the run? 1, 2, 3, 4, 5. Okay. Is it positive? Yes, it is. So 2/5. Don't make it a decimal. I don't want 0.4. Okay? That's what it is. What is the slope of, well, let's make it blue. OB. What's the rise? It rises 5 units. What's the run? That run is 2. Is that line positive or negative? Bryce? Sorry? Negative? Does it tilt to the left? Yes, it's negative. Okay? That one tilts to the right, it's positive. Okay? Anything that looks like that is positive, and from vertical, anything that looks like that is negative. Okay? All the way down to a horizontal line. What's the slope of a horizontal line? 0. Stick it in your noodle. Okay, so that's negative. That's how the slopes compare. You don't see the relationships here. Well, maybe you do if you're really clever. So let's find out. Multiply these together. 2/5 times -5/2. How do you multiply fractions? You have to explain this every year till, kids are in third year university. Do we need a common denominator to multiply? No. You just multiply straight across. -10 divided by 10. What's 10 divided by 10? Well, 10 divided by 10 is 1, and I have a negative, so that's -1, yes. Okay? I only did this once, not twice like they ask, but what happened when we multiplied the slopes of perpendicular lines? What did we get? Do we think we're always going to get that? Why would he ask the question? Yes. Make a guess about the slopes of perpendicular lines. Well, I'm telling you, the slopes of perpendicular lines, okay, when you multiply them, you get -1. How else can we say that? Have a product of minus 1. Okay? So to understand what that says, you got to know what product is. I hope we all know product is the answer to a multiplication question, right? So, always, always, always. Parallel lines, they have the same slope. Perpendicular lines, if you multiply them, you get negative 1. There's another way to say this. Here's our little box. Okay, so parallel lines have the same slope. The lines are perpendicular if the slope product is minus 1. Okay, so again, we can say this backwards. We can take the premise of the statement and switch it with the conclusion. We can say if two lines have the same slope, they're parallel. And then we can say it the other way around. The lines are parallel if they have the same slope. I'm saying the same thing, aren't I? Right? Okay, I could say the car over there is blue. And then I could say, look at the blue car. It's saying the same thing. Right? So, the lines are perpendicular if the slopes, the product of their slopes is minus 1. You can say that the other way around. If you take two slopes and multiply them together and get minus 1, then they must be perpendicular. Okay? We're just going to add one more thing. If I multiply two different slopes and I get minus 1, we know they're perpendicular. Let's solve this for one of the slopes. Let's solve this for m1. So I'm going to divide both sides by m2. So m1 is negative 1 over m2. This is something in math as well. Okay? We could say for perpendicular lines, each slope is the negative reciprocal of the other. Okay? So there's two things about perpendicular lines. The product of their slopes is negative 1, and 1 is the negative reciprocal of the other. That helps us, because if I say line segment AC is 3/4, I'm going to do a couple more examples. So let's call that A. Okay? Well, let's do this one first. What's something perpendicular to that? Do you see what you need to multiply to this to give you negative 1? It's easier to think of this. Just take the negative reciprocal of this. Okay, you flip the numbers. That's the reciprocal. And then you make it negative. Okay, easy as pie. Then note, if I take this and multiply it by that, I do get negative 1, right? Okay? So that's the harder one. Now, what's the slope of a line segment parallel to this one? Let's call it GH. What's parallel to this? If it's parallel to this, it's the same, isn't it? Okay? So a couple of other examples. Let's do B. What if some line AC had a slope of 1/2? What would be the slope of another line segment parallel to this one? 1/2. Okay? Example C. The slope of some line is negative 3. If I'm asking you for the slope of something parallel to this line, what's its slope going to be? Tough stuff, eh? Okay. Some line has a slope of 1/2. What is the slope of something perpendicular to it? I take the negative reciprocal of it. How do I do that? I flip the numbers. Okay, is this, are you having a deja vu of negative exponents here? You should. Okay, and then I take, and I just change the sign. The negative reciprocal of 1/2 is negative 2 over 1. Okay, just flip it, change the sign. How do I flip minus 3? Yeah, okay? That's how you want to see it. Now you see the rise over the run. How do you flip this? Put the 1 on the top, put the negative 3 on the bottom, but I got to take the negative of that. Right? So this is going to be positive 1/3. Okay? Flip the numbers, change the sign. That's all you do. This is perpendicular to that. Okay? Any questions? Guess what you get when you multiply these together? Let's just show you again. If I multiply those, I get negative 3 over 3. That's negative 1. Okay? All right. Determine if these lines are parallel, perpendicular, or neither. What happens if they're parallel? Negative. But we don't care if they cross or not. That's a couple weeks away. If they're parallel, what happens? What do we know? We know the slopes are the same. If they're perpendicular, what do we know? We know one slope is the negative reciprocal of the other one. If either of those cases doesn't happen, they are not parallel or perpendicular. That's your three choices. Okay? The slope of one line is 1/4. The slope of another line is 3/12. Are those the same? They don't look the same. What if I simplify this? 3 goes into itself once, 3 goes into 12 4 times. Okay, now they are the same. Therefore, they're parallel. Right? I mean, I don't know where these lines are. Hey, let's just quickly sketch this. The rise is 1. Let's say 1 went through the origin. Rise is 1. The run is 4. Which direction? This direction, so that it's positive. Okay? I haven't a clue where this line is, but I know it's parallel to it. Maybe it's there, maybe it's here, maybe it's there, maybe it's there, hey, maybe it's there. I don't know where they are, but I know they're parallel. All right, how about these? 5/7 and 14/10. First, let's reduce that thing. Okay? How can I reduce this? 2 goes into 10 5 times, 2 goes into 14 7 times. All right. Are they parallel, perpendicular, or neither? Oh, I got a lot of people yelling stuff out here. These are the reciprocal of one another, but it's not the negative reciprocal. All right? So these are neither. Okay? That's positive 5/7. This one's positive 7/5. They cross, but they're not 90 degrees. They're not perpendicular. One has to be the negative reciprocal. Okay? So, not negative reciprocal, just reciprocal, which means nothing. Okay? All right. P, this is like yesterday's. We got 2 points. Do you think you can find the slope of that? What's our little trick to kind of help us minimize mistakes? Label the point. X, Y, X2, Y2. Remember our slope formula? Do you have to memorize this? It's on your formula sheet. You don't. Okay? If you label the points, it's pretty hard to make a mistake. Okay? But I still see like half of the kids not doing that. That's smarter than that. I don't need to write that down. Okay? Isn't it worth the 3 seconds? Then all you got to do is plug the stuff in, just like Lego. Y2, there it is. That's -2. Minus, what's Y1? There it is. That's 7. Okay? X2, that's 6. Minus, what's X1? 4. So that's -9 over 2, which is, well, can't really reduce that. That's what the slope is. 9 units of rise, 2 units of run in the negative direction. So for you guys, that'll look like that, right? Okay, make sure you go the right direction to make it negative. All right, what is something parallel to this? What's the slope of a line parallel to this? If it's parallel, it's got the same slope. Something perpendicular to that, what's the negative reciprocal? Flip the numbers, change the sign. Okay, one more. This is the tricky one. Because if you cheated yourself yesterday, like I was saying, and you didn't actually use the formula to solve, well, today is going to be that much harder. Two lines have these two slopes, respectively. You know what that means, respectively? That, and it's totally redundant. What it says is this is the first line, and that's the second line. Who cares? Find the value of k if the lines are parallel. What do we do? Who knows? Show of hand. Matt, what do we do? Do you know? Nicole, where are you going? Not right now. You want to see this question, okay? Colton, what do we do? What do we know about parallel lines? The same slope. Well, if this is the slope of one line, and that's the slope of another line, and they're the same, then how do we let them be the same? Is there some kind of a math expression that says same? Like equal? That's it. The slopes are the same. They're parallel. Can I solve that for k? Maybe. I hope so. One equation, one variable. I should be able to solve that for k. All right. Cross multiply. Okay. Which means I'm going to go negative 3 times 5 is equal to k times 4. Now I don't have any fractions. Okay, now it's a lot easier. All right, that's easier. Like, let me explain the big kid way. Cross multiplying actually algebraically makes no sense at all, but we teach it because it works. The big kid way is, I want k by itself. I got to get rid of this 5. Let's multiply both sides by 5, cancel it out. Okay, so I have 5 times negative 3 over 4. Well, what happens here now if I divide this by 4? I got the same thing, don't I? Okay? So either way, like this is, I want k by itself. How do I get rid of 5? Just multiply both sides by 5. Okay, but lots of people like cross multiplying. So k is negative 3 times 5 over 4. Can I reduce it? No. Okay? That's what k is, if these two lines are parallel. Okay, it's ugly, it's a fraction, but that's what it is. Now, what do we know if these things are perpendicular? If these are perpendicular, one's the negative reciprocal of the other. I've seen people do this that way, but I would recommend you do the other thinking, which is what? We know two things about perpendicular lines. Okay? One's the negative reciprocal of the other. What else do we know? The product of the slopes is minus 1. If I multiply these together, if they're perpendicular, then what does that equal? Minus 1. Okay, that's a lot easier than trying to think, well, the negative reciprocal, how do I make it work? Okay, just multiply it out. Negative 3 times k over 20 is minus 1. How do I solve that for k? Got to get rid of the negative 3, got to get rid of the 20. Okay, if you like cross multiplying, you would go 20 times negative 1 minus 20 equals negative 3k times 1. Okay, that's fine. How do I get rid of 20 here? What if I multiply it to both sides? It's gone. So then I have minus 3k is minus 20. How do I get rid of the negative 3 now? Divide it away. So k would be negative 20 divided by negative 3 is positive 20/3. Can't reduce it. Leave it like that. Okay? All right. That's it for your big quiz Thursday. Got some review stuff tomorrow.